Hi everyone, today we will revise the common source amplifier which we have seen in last lecture, and we will see some example. Okay, so in common let me draw the common source amplifier configuration. Okay, so in common source amplifier we give input to the gate, right, and take output from the drain side. So I'm giving input to gate. Okay, this is for biasing V naught, and I'm taking output from drain, right? And this is RD, this is VD, VDD. Okay. So now while making, we have to calculate gain, Z out and Z in. So if you will want to calculate this, you can draw the small signal model of this configuration. So, okay, let me make for MOSFET. There is a gate, there is plus minus VGS, then there is source. You can see source is ground, okay, and then there is a drain. In drain terminal, it is like this GM VGS, right? This is drain. Now see, for calculating the making the this small signal model, you have to ground the DC source. So you have to ground this. Okay. So means drain is having RD like this. RD is there, and after RD there is a ground. Then ground. Okay. We have to make it ground, right? When we want to draw the small signal model. At G terminal, you can see there is V in, and this DC source will be removed. So it is V in. Now see, this and this are in parallel, so VGS is equal to V in. Okay, so this VGS will become what? GM V in it will become. Okay, because VGS is equal to V in. And there we are calculating V out in between RD and this terminal. See, okay. So what is AV? AV is equal to V out divided by V in. Okay. So to calculate these, you can apply KCL or on this node, or you can see this is plus minus V node, right? You can apply KVL there. I'm taking one another color. Okay, there you can apply KVL. So what it will be from there to there you are going. So it will be plus V out, right? And then you are coming to this. What is the voltage drop here? Voltage drop here will be the current flowing through this RD and into RD, right? So what current is flowing through this? This GMV. Okay. So what is the direction of this current? This. So this is current. This current is coming like this. So there is open circuit. So all current is coming like this, like this. Means this is positive. Yeah, this is positive and this is negative. Okay. Since the current is going like this in this direction, this is positive, I'm taking black color. This is negative terminal, this is positive. Why? Because the current direction is like this. Okay, so V out will be V out, then there we will go, so it will be plus since minus is there, plus. And what is the current value? Current is GM V in. Okay, and the resistance is RD equal to 0. So V out will be equal to minus GM RD dot V in. We want to calculate AV, which is equal to V out by V in. So AV equal to V out by V in. V in will go in left side. So the remaining part will be GMRD. Okay, so this is the gain. Now we want to calculate Z in. So Z in, see, Z in is equal to what? V in by I in. What is I in? I in is 0. Okay. Why it is 0? Because of the high impedance of the gate. No current will go inside that. So V in by 0 is equal to infinite. So Z in is infinite. And all this we are doing by considering lambda equal to 0. Channel length modulation we are not considering. Okay. Now we have to calculate Z out. So whenever you want to calculate Z out, you have to do some changes in this configuration. So you have to keep V in 0. Okay. You have to ground it. You have to short it like this. This is ground now. Okay. So VGS will become 0. Right? And this one also will become 0. So this value of this current source will become 0. So there is no use of it. We can remove this. Okay, so this part is removed. This much part. What is remaining? Remaining part is RD. Okay, and V out. So how to calculate Z out? On Z out means output side, you have to apply one input voltage Vx and voltage DC voltage. Okay, and give current will go Ix. Calculate Vx by Ix, that is your Z out. Okay, so Vx by Ix will be what? Vx is equal to Ix into Rd. Simple. So Vx by Ix equal to Rd means Z out equal to Rd. Okay, so this is about common source amplifier. Okay, we are not considering this R naught here. Okay. Okay, let's consider this R naught and let's see what will be the change in the gain and output impedance. Okay, so let me make again. So this is MOSFET. Same here, that input and the biasing. Okay, and there will be R naught. From middle of this, we are taking V out. Okay, let's try to draw the uh, small signal model of it. So at input side, there is input voltage. What is that? V in. It is grounded, and there is VGS. Now on, see, source is ground. Now on drain side, there is voltage controlled current source. VGS I'm writing, it's V in. So it will be GM VGS. So VGS is what? V in. So you can directly write V in. Now from drain, this is drain terminal, this is source, this is gate. From drain there is going V out, right? And there is a R out, this which is connected to drain and source. So let's do it. Drain and source, this is R naught, and from V out terminal to ground, this will be ground. While I told you that whenever we want to do small signal analysis, we have to make DC ground. Okay, so this RD will be connect where? This terminal somewhere and to the ground. You can make it like this. If it is on top, we are showing, so we can make on top. You can make it like this also. Okay, RD. Okay, now, So the voltage on these terminals is what? It is V out. Okay, right. Now for calculating gain, what we have to measure? V out by V in for calculating gain, voltage gain. So let's take mm, a current is flowing in this direction, that is I1, and one current is flowing in this direction I2, and there the current flowing is this much, GMV in. And let's apply KCL on this terminal. Okay, so what will be the KCL? Applying KCL, sorry, applying KCL. Okay, so outgoing current will be negative. So first let's take this one current. It is going outside from the terminal, so it will be negative. So it is GM V in. KCL, you know, everyone, that incoming current will remain positive, outgoing current will remain negative. So it is I1, I2, I3. So according to KCL, it will be minus I1 plus I3 plus I2 equal to 0. So this is KCL. So same we are doing here. Okay, so it is outgoing. So this is GMVN, and same I1 is also outgoing. I2 is also outgoing. Okay, so now GM V in, what is I1? I1 is V out by, what is the voltage here? It is V out. So V out by R naught is I1. So let's write V out divided by R naught minus V out divided by RD equal to 0. Okay. Uh, yeah. So keep this V out outside, and inside will remain R naught plus RD. Sorry, 1 by RD. 1 by RD equal to minus, sorry, plus GM V in. Okay, let's go a bit down. Okay, yeah. So this equation we have. Now we have to take LCM here. So LCM will be R naught dot RD, and on top it will be RD plus R naught. Okay, so this is V out. You can take negative on this side, means GM V in. We need V out by V in, so take this thing on this side and bring this V in on this side. So V out by V in will be equal to minus GM into RD plus R naught divided by R naught dot RD. Okay, which means minus GM into R naught parallel RD. Okay, if R naught is very high, okay, I'm taking one condition, R naught is very high as compared to RD, then what will happen? Minus GM into RD plus, okay, yeah, I did some mistake. Yeah, it will be dot. Okay, it's in multiplication. This will be plus. This will go on top. This will come down. Okay, so it will be R naught divided by R naught. So R naught cancel. So it will be minus GM RD. Okay, so this is your gain AV. Sorry. Yeah. Okay. Let's go to the next page and calculate the R Z out. Z in will be infinite. Okay. Since the current incoming current to the gate terminal is 0. right? So it will be 0. So for calculating the Z out, we have to make V in ground, then plus minus VGS, and this is ground, right? So that current source will be 0 there because of VGS is equal to 0, so that will be 0. Okay, so no need to use it. So this is R naught, okay, and this is RD, and there is one voltage Vx, and the current is going Ix. You can look like that also. What is straight you can see without using this. If is you will look like this, there is nothing, just R naught and RD are in parallel. Okay. If you want to use like this, you can use it. So see, Vx will be equal to Ix into R naught parallel RD. Okay. So Vx by Ix will be equal to R naught parallel RD. And so R naught parallel RD is if we calculate this value, so it is R naught plus 1 by RD, means it is R naught RD plus R naught, means it is R naught dot RD into RD plus R naught. Okay, so this is Z out. Okay, and if I am keeping R naught very high, that is R naught as compared to the RD, then Z out equal to R naught dot RD, and this is R naught. Okay, this will be cancelled out, so it is RD. So Z out equal to RD. So this is Z out. Now let's move to the next page. Okay, I want to discuss one example. So let me draw. So it is like this. There is input, and this is V bias. This is 1.2 volt. This is 2 volt. RD is 3 kilo ohm, and there is V out, and this is uh, N MOSFET. So it is RD. This is V in. Okay. Now, what else is given? W by L. Yeah, W by L equal to 10, and mu NCOX is equal to 100 microampere per volt square, and VTH equal to zero point 0.5 volt, lambda equal to 0. Okay, that I'm considering. So see what I want. Why I'm taking this example. What I want to understand. See, there is a common source amplifier like this. CS, I'm giving input, I'm taking output. So the gain of this common source amplifier is AV. Okay. Now I want gain equal to 2 times of AV. Okay. What can we do that we will see? Okay. So first of all, let's calculate gain of this example. The gain. Okay. To calculate the gain, what you need minus GM RD is the gain. Okay. This is the gain. So for calculating gain, we have to calculate ID. Okay, ID we have to calculate because the GM is equal to what? GM is equal to 2ID divided by VGS minus VTH. Okay, right. So how we can know that this MOSFET is in saturation or it is in uh, triode region? What region is it? So we can't tell, right? Because for saturation condition is VDS should be greater than VGS minus VTH. Okay, so VD we don't know. For calculating VD, I mean this VD, this is equal to VD only. For calculating this VD, you have to calculate this ID. And for calculating ID, there is two formula. One is one equation is for saturation, and other equation is for triode region. Because we don't know that it is this MOSFET is in saturation or triode, so how to use the current equation? So we can do one thing. We can consider that MOSFET is in saturation region, okay, and we can calculate ID, and after calculating ID, we can calculate the VDS, and we can see that condition is satisfying. When this condition is satisfying, then the MOSFET is in saturation, and if not satisfying, then it was in triode. So again we have to go back and use the triode current equation. Okay, so what is ID? ID equal to mu n cox w by l VGS minus VTH square divided by 2. Okay, so this is 100 micro was given mu n cox, so it is 6, and what is w by l? It is 10 to power minus, it is 10. The value of it was 10 divided by 2 into what is VGS? 1.2, right? We are considering first V in equal to 0. Okay, since we are calculating the biasing, so consider V in equal to 0 and calculate. So what is VGS? VGS is nothing but 1.2 C. This is VGS. If it is 0, then VGS equal to 1.2. Okay, so now what is VTH? VTH is 0.5, then square. So it will be 10 to power minus 3 will remain on top, divided by 2 into 0.7 square equal to 10 to power minus 3 divided by 2 into what is that? It will become 0.49. After cutting, we will got okay 4 and 5. Yeah, so it will be 0.245 milliampere, or we can say 245 microampere. So we calculated the current. Okay, now can we calculate the VDS? So for calculating VDS, see, I'm going again on top page. See, VDS, this is VDS, right? Okay, so if you will apply KVL on this side, you will see 2, okay, minus, this is plus, this is minus, so it will be minus RD into ID minus VDS, okay, equal to 0. So VDS equal to what? 2 minus ID RD. Okay, let's use it. So VDS is equal to what? 2 minus ID was 0.245 milliampere into the resistance, that is 3 into 3. That was 3 kilo ohm, right? So it is like this. So what will be the VDS? VDS will be equal to, this will be cancel out. Okay, So it will be equal to 2 minus uh, 70. Okay, this much. So after subtracting, we will got 1265 volt VDS. Okay. Now see, what is VGS minus VTH? VGS is what? VGS is 1.2 minus what is VTH? 0.5. So it is equal to zero point 0.7 volt. So you can see VDS is greater than VGS minus VTH. Right? So condition is true, means MOSFET is in what? Saturation region. So it's correct. Now, now let's calculate GM. GM equal to 2ID VGS minus VTH. What is 2? ID is 0.245 10 to power minus 3, and this is 0.7. It is 1.2 minus zero point 0.5, so it is 0.7. And after doing cutting everything, we will got 0.7 micro Siemens. Okay. Right? Or we can write it like this: 1 by 1.43 kilo ohm. Okay. Now we can calculate gain easily. AV equal to minus GM dot RD. Okay. So what is GM? GM is zero point 0.7 into 10 raised to power minus 3. What is RD? RD was 3 kilo, means 10 to power 3. So it will be 2.1. That is gain. Okay. Minus 2.1. Now, what I want, I was telling you that I have a common source amplifier. There is, it have gain of this, but now I want gain double of it. Okay. I want what? I want minus 4.2. 4.2 gain I want. So what can I do? How can I increase the gain? How can I double the gain? So you can see the formula of gain, that is equal to minus GMRD. So you can say directly we can double the RD and the gain will be double. Okay, right? So you can make it 6 kilo ohm, and what? The gain will become double. Simple. But no, we can't do like this. You know that if we are increasing RD, okay, our MOSFET can go in triode region, okay, which we don't want. Okay, it can go in triode region. So how can it go in triode region? Let me explain. So the condition for MOSFET to be in saturation is this, right? And you know the VDS, VDS is equal to what it was, 2 minus ID into RD. Okay, so if you are increasing RD, what will happen? This VDS will reduce. Okay, if it is reducing, what can happen? Our MOSFET can go in saturation region. It can, this can be greater than this. Okay, so let's see. VDS will be what? If I'm keeping our RD equal to 6 kilo ohm. Okay, I'm doing double. It was previously 3 kilo ohm. I'm keeping 6. Okay, so it will be 2 minus, and ID is constant, right? ID is constant. So ID was how much? K ID was 245 10 to power minus 6 into RD is 6 kilo ohm. So it will become 2 minus 2.45 into 6 into 10 to power minus 3. So what I will got? I will got here 2 minus 1.47. Okay, means 0.53. Okay, this is new VDS after doubling the RD. And what is VGS minus VTH? That is zero point 0.7. Now see, VDS is not greater than VGS minus VTH. It is 0.53 and it is zero point 0.7. So what is now situation is VGS minus VTH. This is the situation and MOSFET in triode region. So you can't increase RD like this. Okay. What else we can do? Okay. So AV was what? Minus GM RD. You can increase GM, right? What is the formula for GM? GM is equal to root 2 mu n COX W by L ID. So what you can say? You can increase ID, right? But if I increase ID, then also MOSFET can go in triode region. MOSFET can go in triode region. Okay. How? See, what is VDS? VDS was equal to 2 minus ID RD. See, ID you are increasing. It can go in triode region. So you can't increase ID like this. Okay. So now what is next? You can increase W. Okay. So by increasing W, you can increase GM. Okay. But you can increase W up to infinite and you can get infinite GM, keep very high and we can get very high GM means very high gain you will got. No, that's not true. Okay, if this is like this, you are keeping very high W, then this condition won't be valid. So the equation will become in this case ID 1.5 VT. Okay, so it will be this. So up to a fixed amount, you can increase the W. Okay, so what we have learned today, we learn that uh, common source amplifier, the gain, we calculate the gain. Okay, what we calculated? Gain we calculated, Z out we calculated, Z in we calculated without RO and with RO we calculated this. Okay, then second we saw one example how to calculate gain of a MOSFET, and third how can we increase gain that we saw. Okay, so thanks a lot for watching the video, and if you like the video you can subscribe my channel, you can like the video. Thanks a lot for watching it. Let's meet in next lecture. Yeah, thank you.